Hello people, I'm Bharat Acharya. Welcome to a new video. So in today's video we're going to learn 8085 programming. I'm going to teach you basics of programming and then I'm going to take it to a higher level. We'll start with a simple program first to add two numbers. We'll do it in the most simple way using LDA and STA instructions. These are the instructions people who start programming use. Okay, they are the most basic way of doing a program. Then after we finish that, in that program of course we're going to take care of carry also, so I'm going to teach you how to handle carry. Now carry is not something that happens in one program. If you know how to handle carry, you'll be able to do it in various programs because that situation arises across 40 to 50% programs that you do. Then I'm going to teach you the same program of add two numbers but how to do it in a professional way. College exam, you do it either of the two ways, you'll get full marks. But your life doesn't end with adding two numbers. You want to do serious programming. Now when you want to do serious programming, you want to start using M, the memory pointer. That's the strongest tool of 8085 programming. So I'm going to teach you with this example of adding two numbers how to do the program using M. Once you know that, you'll be able to do big programs which involve major loops because in those programs M becomes your best asset. Anyway, after that we're going to take it a level higher. I'm going to do block transfer programs. These are regularly asked questions. So first we're going to see a normal block transfer, transferring a block of data from one place to the other. Why does this program keep coming a lot? Because where is it used? It is used in copy paste. Now copy paste is something that we do every day. So when you're doing it next time, you copy a set of data, Control-C, Control-V or Command-C, Command-V if you're using Mac. When you do that, you should strike your mind that I know how to write the program for doing it. So I'm going to anyways teach you a normal block transfer. Then I'm going to teach you inverted block transfer. The block of data containing 1, 2, 3, 4, 5, when it's inverted, it should be 5, 4, 3, 2, 1. So it's also called infix, postfix or string reversal, whichever way. Different universities call it different way, but basically it's an inverted block transfer. Then I'm going to show you how to exchange two blocks. This is a whole block of data, this is another block of data. By the time the program is over, this should be here, this should be here. So that's what this video is going to be all about. You know what I've been doing. I have been giving all introduction videos on YouTube. The whole video of architecture of 8085 and the basic introduction of microprocessors is there for everybody to watch because I love this subject and I want more and more people to be aware of the subject and start enjoying learning it. But that's it. More than that, if you want to really understand the whole subject, please come to my website. It's called bharatacharyaeducation.com. We've also created our app. The app is now in the market and people are using it. With the app, you can, whether it's on the website or on the app, once you make the subscription is for 999 rupees, less than 1000. Once you make that subscription, you can watch all the videos of 8085, okay, not one, all the videos of 8085 as many times as you want to, so that you can grasp as much as you can. The advantage of using the app is in the app you're also allowed to download the video, like you do it on any other platform, like you do it on YouTube. So you can download the video and watch it from your phone instead of using internet data all the time. So when you're in college, just keep the video for downloading. Keep in mind it's a video, so it's not going to be downloaded in a flash. These are high definition videos, so it's going to take time to download. So keep it before the lecture starts. By the time the lecture is over, your video is downloaded. Whenever you're free in college or at home, you can watch the video again and again. You can of course delete it once you're done watching it and so on. Also in the app I have provided the notes, my book. So topic wise, depending upon the topic, whose video is this. So right now if it's for this video, the notes along with that will be there in the app. You just hit a button, you'll be able to see the notes also. So it's especially useful in theory answers. So you not only understand the logic, but you also understand what to write in the exam. Anyway, so all that is there in my app and on my website. Come along, hope to see you there. Now we begin. Okay. So our first program is to add two numbers. So this is how the question will be there in the exam. Write a program to add two numbers. Either they will give the addresses or you assume. So let's say the numbers are stored in the memory at the location 2000 and 2001. Now both of them contain 8-bit numbers. You tell me, when you add two 8-bit numbers, answer is how many bits? Exactly 8 bits. Like when you write add B, operation is A plus B, the result comes in A. So answer is 8-bit, no doubt. That is called the sum. And there is a possibility of a carry. Now what are the possible values of carries? 0 or 1. You get this clear? Carry can never be 2. 9 plus 9 cannot be 20. 99 plus 99 cannot be 200. Similarly, in hexadecimal system, both these numbers are 8-bit numbers. So worst case situation, there will be FF. FF plus FF is 1 FE. Like 99 plus 99 is 198. Similarly, FF plus FF is 1 FE. In 1 FE, FE is the sum, 1 is the carry. So basically, carry can only be a 0 or a 1. So you got to store both sum and carry. So they will be requiring two locations, 8-bit for the sum, and though carry is 0 or 1 will be stored as a separate location. So we'll be storing sum at 2002 and carry at 2003. Now here is another thing to understand. If they don't tell you where to store the sum and carry, please store it correctly. There is a rule followed always. Lower byte, lower address, higher byte, higher address. Say this again please. Lower byte, lower address, higher byte, higher address. Now 2000 and 2002 and 2003, this is the lower address, this is the higher address. So here the lower byte should come, here the higher byte should come. Now between sum and carry, which is higher? The carry, of course. Why? Carry comes after the MSB of the sum, so it is the higher byte. Like for example, 9 plus 4 is 13. 13 means 3 and a carry 1. Now 3 is in the units place, 1 is in the tens place, so it is more significant, so it is called the higher byte. Are you clear? So we will store the carry over here as the higher address, the higher byte at the higher address, lower byte at the lower address. Now what's the procedure? As I said, I'm going to do the program in the simplest way possible. Now I have an advice, okay? Right now just disconnect from everything else that you're doing and focus here, especially if you have never written 8085 programs. Okay, once you understand one program completely, it will give you massive confidence to understand more programs, and you never learn programs, you learn programming. I'll be teaching you a lot of skills over here, which only if you're fully concentrating, you'll understand every word I'm talking. Okay, so please pay attention and disconnect from everybody else. Now, you want to add these two numbers. Obviously, to add them, first of all, you need to take them into registers. So what are you going to do? Take the first number into some register. So here is your first question. You will take it in which register? Tell me. There are 7 registers, A, B, C, D, E, H, L. You will take this number in which register? Yeah, A. Why will you take it in A? Because the instruction to do this is called LDA. Get this clear, my friend. There is no LDB or LDC. So what is the first thing you understood from here? Whenever you want to take data from the memory, the register in which you will get the data is A. The gateway into 𝗵𝑝 is A. Once the data comes in A, you can transfer into any other register, but it will come in A. Are you clear? So take the first data in A. Now, immediately transfer it into some other register like B. Why? Because you're going to take the second data also in which register? A, exactly. So when you take the second data in A, you don't want to lose the first one. So take the first number in A, transfer it into B, take the second number in A. Will you be able to do instructions for doing this much? Good. Now, add these two numbers. Add B, so it will do A plus B. The result will come in A. What is there in A? The sum, which we're going to store at 2002. At 2003, we're going to store the carry. Assume the carry is in C register. We will get it, of course. Now, assume the carry is in C register. We'll store the sum from A to 2002 and the carry from C to 2003. So now the only thing left in our mind is how to get the carry in C register. That I'll teach you as we do the program. First, let's do the instructions for doing this much. Come on. Get the data of 2000 into A. Come on, give me the instruction. LDA 2000H. Please tell me, did you understand this? So A gets the data from 2000. Immediately transfer the data into B. Move B, A. Exactly. Was it move A, B or B, A? B, A. I always tell this in the class. See, right now I can't see you, but you got to follow this if you want to learn properly. Say instructions. There's a big difference between thinking of them and saying them. When you think of them, you're 50-50 about what you're going to say. When you say, you commit. So what happens? Either you'll end up being right or wrong. If you're right, great. If you're wrong, great, because now you know what is wrong, so you will not make the mistake again. So much better than just thinking of it is saying instructions. Okay, it's going to help you. Okay, so you took the first number in, transfer into B. Take the second number in A. Come on, give me the instruction. Second number in A. Good. LDA 2001. Now you've taken your two numbers in A and B. Now add A and B. Come on. Add B. Exactly. Now when you did this, who has what? A has the sum. The sum is in A. Store the sum at 2002. STA 2002. Please tell me, did you understand this? We have stored the sum in 2002. Assume the carry is in B. I will put it. Can you see I have left space? I'll put it. First, let's just store the carry. Assume the carry is in C register. The carry is in C. From C, you're going to store it at 2003. How are you going to do it? From A, you store it at 2002 by writing STA 2002. From C you will store it at 2003 by writing 𝗕𝐶 2003. No, there is no such instruction. There is an 𝗕𝐶, but that is set the carry flag. That is not store C register. So what did you understand? If you want to transfer from C register to a memory location, you have to first get it into A register. Exactly. What did I say? I am the 𝗕𝗵𝗿, you are the memory. Between the two of us, there is A register. I want data from memory, it has to come into A. From A, it will go wherever you want. Similarly, if I want to send data to memory, I have to put the data in A and write STA. There is no STB or STC or STD. Are you understanding what I am saying? So, from C, first take the data in A. Now, come on, give me the correct instruction. You want to transfer the value from C register to A register. Come on, come on, come on, come on. Move A, comma C. You always write the destination first. It's destination, comma source. So, you will transfer from C to A. Now, from A, you will store it at 2003. STA 2003. Done. End the program by writing halt or return or RST1, whatever your college teacher writes. There are different ways of ending the program. Most common is halt, so I am writing halt. So, now the only thing left to be done is get the correct value of carry into C register. Now, who has the carry? The moment we do this addition, carry comes into the carry flag. So, what we need to do is from the carry flag, get the carry into C register. I repeat, from the carry flag, get the carry into C register. Did you understand this? From carry flag, get into C. Now, can you write move C, comma carry flag? No, that is not possible. There is no such instruction. So, here you need to use some logic. If carry flag is 1, make C register 1. If carry flag is 0, make C register 0. Did you understand this? We've already done the code for storing C register at 2003. Our job is just to get the correct carry into C register. So, I say again, if carry flag is 1, make C register 1. If carry flag is 0, make C register 0. Now, C register can have only two final values, 0 or 1. Don't try to find out both values. That is stupid programming. We say this, when you see somebody's code, you come to know instantly whether that person is serious about programming or is just writing to get it done with. If you know something can have only two values, never try to find both values. Assume one and work on the other. That makes your work half. C register could have only two values, a 0 or a 1. 𝗵𝐶, I have started my program by assuming that there is no carry. What does this mean? If there is, after this addition, if there is no carry, my program is already working without doing anything. There were only two possibilities. There could be either a carry or no carry. I have assumed no carry. So, if there is no carry, I have to do nothing. Please tell me, did you understand? So, now I have to handle two cases or one case? Only one case. Which case? If there is a carry. Now, if there is a carry, C register should become 1. To make C register 1, you can write 𝗵𝐶, 01, or you can write INRC. What do you write? INRC. INC was used in 8086, so you write INRC. Now, when you write INRC, INRC stands for increment C. Now, this line, increment C, should be written only if there is a carry. If there is no carry, I should not do this. So, come here. You initialize C with 0, you took your first number, transferred into B, took the second number, added it. Here, you have to make a decision. If, I am saying it in English, then I will write the instruction. If there was a carry, I should do this and continue. If there was no carry, I should jump over this line and continue. Please tell me, did you understand this? If there was a carry, I should do this. If there was no carry, I should jump over it. The instruction is JNC skip. This is skip. JNC stands for jump if no carry. I repeat, jump if no carry. So, if there is no carry, directly skip and store the result, because you assume C to be 0, it is valid. If there is a carry, it will not jump, because I have said jump only if there is no carry. So, if there is a carry, it will not jump. Now, if it will not jump, what will it do? Will it sit there? If it does not jump, it by default it will go to the next location. That means it will make carry 1 and then go ahead. That means bottom line, this instruction will only be executed if there is a carry. If there is no carry, you will skip this instruction. Please tell me, did you understand this? Yes, is the idea of handling a carry clear? That was the thing I wanted you to learn from this program. Carry is not something that happens only in this program. You will come across the situation of carry in 25, 30, 40, maybe 50% of programs that you do. After this, in any program, if there is a carry, this is how you are going to deal with it. What's the procedure? Tell me. Take a register like C. By default, initialize it with 0. So, you assume that there is no carry. Do whatever you want to do till the part where carry could be produced. Now, here you want to check carry. If there is a carry, increment C register. If there is no carry, jump over the line where you are incrementing C register. What is this label? Skip. It's a label. You can give it any name you want to. Because I'm skipping an instruction, I've given the name skip. You could have called it down, then you'll be writing JNC down. That's just the name of a label, whatever you want to do. You're not skipping because I've written the name skip. You're skipping because of this instruction JNC. JNC stands for jump if no carry. So for the last time, let's just repeat the program, then we go ahead. You've initialized carry as 0. You've taken the first number in A, transferred the number into B. You've taken the second number in A. You have added the two numbers. I think up to here everybody is okay. Now, at this point there could be two things. Either there could be a carry or there could be no carry. You assume that there is no carry because you've initialized C as 0. So if there is no carry, directly jump and come over here. If there is a carry, make C 1 and then come over here. So by the time you've come over here, C register has your actual carry. A has the sum, C has the carry. Store A at 2002, STA 2002. You want to store C at 2003 but cannot be done directly. So from C first get the number into A, from A store it at 2003. From C get the number into A, from A store the carry at 2003 and end the program, halt. That was your program. Please tell me, did you understand this? So this was a program to add two numbers. Now, what are we going to do next? Again, a program to add two numbers. Why are we doing it again? This is how a college student will do a program, or a child, a person who has started programming, first day of programming. This is how he or she will write the program. If you ask a professional to do this, which is what you are going to become, which is what you are aspiring to become. Tomorrow you want to be a person who gets paid for writing programs. You want companies to hire you, sit over there, write good programs for them. If you give this program to a professional, they will have a good laugh over it. You don't do programming like this in the real world. Yes, you start learning programming like this. This is the basic tools. You got the idea of to work with registers. But you want to do real serious programming, you have to start using M. M stands for what? Memory pointer. M is the best tool of programming. Whenever you want to access a series of locations which you need to do for real world programming, you need to use M. There are various programs which can be done only using M. So the sooner you start learning M, the better position you are in when you get into complicated programs. Now I don't want to introduce M when I'm doing some real crazy logic, because A, you'll be struggling with the logic, plus you'll get confused with what M is doing. So a program that you've already done, I'm showing you how to do the same program using M. The moment you'll finish, you'll realize how wonderful this approach is as compared to this approach. Here you are tied up with a lot of rules. Here it gives you a lot of flexibility. Anyway, so we are about to start the same question again.